Hello students, once again welcome to Physi Dive, and this is your teacher alexi rajan. Today we are going to study a very important topic of class 11, that is motion in a straight line, and the topics are velocity, speed, average speed, instantaneous velocity, instantaneous speed, uniform velocity, non-uniform velocity, uniform speed, non-uniform speed. So without wasting time, let's dive in straight to the class. So we are going to study about the speed and velocity. So imagine that Suman and Revati both are standing at this particular point A. This is the end point B. Both Suman and Revati move to this particular point B. So what happens there? So just say that they start at a particular time. So the starting when they are moving from here to here at this particular point. So Suman reaches here at a time of 2 seconds. Just imagine that the time is 2 minutes. So within 2 minutes, Suman has reached from A to B, whereas Revati to this particular point in 3 minutes. Okay. Speed says about how fast an object or any person is moving from one point to another, or how much is the distance travel per unit time, and that gives you the idea of speed. Okay, so what is the SI unit of speed? So meter per second, right? Time, it's second. So this is a case there. And one more thing you need to keep in your mind is that speed is what type, which quantity? There is no specified directions here. Why? Because distance, they don't have any specified direction. They can be moved, or any object can cover any place, or someone can move like this, Revati can move like this. So there is no specified direction for distance. So speed is distance by time. So we can say that thing speed is also a scalar quantity. Now, what do you mean by velocity? So velocity is nothing but it is a displacement by time. So what is displacement? Change in position. So if there's a coordinate system, so there's the origin, an object, imagine that an object is here at time t1 or t0, the person is standing at the origin. This is the origin. Okay, now at time t1, this person has displaced or reached to this particular position. The position of the object or person has changed from O to A in time interval t1 minus t0. Okay, so within that time interval, what is the difference in position? That will give you what? The displacement. And the change in displacement per unit time is nothing but it is a velocity. So we can say that thing change, or if this is x0 and this is x1, then x1 minus x0 divided by t1 minus t0. Why? Because x1 is the displacement at time t1 and x0 is the displacement at time t0. So this is the case there, or simply we can say it is delta x. So here also the SI unit, what is displacement by time, right? Displacement have a clear-cut idea about a direction. That is, it is the shortest distance traveled by an object from one position or one point to another point. So definitely the direction comes into play. So we can say it is a vector. Uniform speed and non-uniform speed. So uniform speed can be said as if an object is moving at a distance or it is covering equal distance in equal interval of time, then we can say it is a uniform speed. So just imagine that there is an object here. This object is having, let this be 0, 2, 4, 6. If this particular object A is displacing equal displacement in equal interval of time, that is at the first 2 seconds, if it is moving 2 meters, the next 2 seconds, that is 2 to 4, that is 2 seconds, 2 meters. And then again, the next 2 seconds, if it is displacing 2 meters, then we can say that at equal interval of time, the body is covering equal distance. Then we can say it is a uniform speed. And one more thing you need to keep in your mind is that the intervals can be very large or it can be infinitesimally small. Now, what about non-uniform speed? In this case, we can say if an object is covering unequal distance in equal interval of time, however small the intervals be, then we can call it as what? Non-uniform speed. Now just imagine that the first interval in 2 seconds, the object has reached here. Next 2 seconds, if the object has reached somewhere here, next 2 seconds, that is, we can say that unequally it is moved. That is, first 2 seconds, the object has reached, first 2 seconds, the object has reached 2 meters. And the next 2 seconds, the object has reached to 6 meters. Then 2 seconds, the object has reached to 7 meters. Here all we can say within that short span of 2 seconds, in the first 2 seconds it has moved 2 meters, in the next 2 seconds it has moved 4 meters, then only 2 plus 4, that is 6 meters, then only it will get 6 meters, then the next 2 seconds it has covered 7 meters, that is the next interval it has covered only 1 more meter, that is 6 plus 1, that is 7. That is, there is a discrepancy in the movement, or discrepancy, there is a difference in movement, that is they are not covering equal distance. So we can say that thing, that this is a non-uniform speed, it is having a non-uniform speed. So that's all about the uniform and non-uniform speed. In the case of velocity, whenever it comes in the case of velocity, you just change that thing into, instead of distance, you change that thing to displacement. Let us see that. So now you can see in the screen what is velocity, what are the different types of velocity. It's also uniform velocity and non-uniform velocity. Here also you can see the definition goes like that. Uniform velocity is defined as whenever an object is having equal displacement in equal interval of time, however small the intervals be, then we can call it as what? Uniform velocity. You can call it as uniform velocity. Whereas if an object is moving unequal displacement in equal interval of time, then however small the intervals be, then we can call it as a non-uniform velocity. Here also the definition goes with the same structure, but you need to change that distance to displacement, that's the only thing. Here also the example will be the same, that is, if you can see in the first example, the body has displaced from this position to this position in 2 meters. And the next 2 meters, it has moved to this position. Here also, the same thing. So displacement or change in position is same throughout, in that given interval of 2 seconds. And here in the second case, but you can see in the first case, the object has displaced to 2 meters in 2 seconds. And the next, it has displaced in 2 seconds. You can see that it has displaced 6 meters, or we can say from the origin. That is, there is a change. The displacement is not equal throughout. So we can call it as what? A non-uniform velocity. And that's a case about uniform velocity and non-uniform velocity. Now, a small thing. What do you mean by average velocity and instantaneous velocity? So I have a car here. So I'm just starting from my hometown and I'm moving to a school here. Just imagine that it's your school. So I want to meet you guys and I'm coming to this particular school. So on the way, I'm just riding. I've started from 0 meter per second. That is, my speed is 0 meter per second, right? So I had started, and sometimes I got a clear road in front of me. There is no block, nothing is there. So I started. I just put my accelerator. I just pedal my foot. I just step foot on my accelerator, and you can see that the vehicle is moving from 60. It started from 40 meter per second. If I see my speedometer, then I can see it is 40 meter per second, and then sometimes it is 60 meter per second, and suddenly I can see there is some hump on the road. So here is a hump on the road. So I just applied my brakes. So it has come to just say 30 meter per second. And then I'm just moving. Suddenly there is a market there. So a lot of rush, traffic, people, and to again apply brake, and you need to move very cautiously. So it is 20 meter per second like that. And then I had reached your school. So here the issue is that no object can move with that uniform speed and velocity, because there will be in nature, in a practical way, I'm saying in a practical condition. So in such a case that you can see, I had changed my speed according to my scenario, situations and all. So here there is no uniformity. So suddenly I want to change this thing. So if I want to just express my speed, then it is not possible that I can say that it is 60. I had just moved from this particular hometown to this particular school with 60 meter per second, in 60 meter per second. I cannot say like that. So there comes the importance of average speed. So there, the average speed is taken as total distance by total time. In the case of average velocity, we can say it is a total displacement by time. So this is the practical case of this average speed and average velocity. So just imagine that an object is moving with different speeds from point A to B. Okay. So in this case, what I can express is that I need to find out the average speed. The condition is that the object is moving different distances in different speed. So what do you mean by different distance in different speed? Just imagine that an object is moving from A to B, and then he starts and move to C. Here you can see that different distance. The object is covering different distances, that is from A to B and B to C. Here the object is covering different distance, right, in different speed. So here say it is covering from x meter per second. So here the person is moving from B to C in y meter per second. Then how can I calculate the average speed there? So the issue is that we need to find out, or the idea is that we need to find out the time taken by the object from here to here and then here to here. Say this is S1 and this distance is S2. Then total distance will be what? S1 plus S2 divided by what is total time taken? Simple mathematics, simple physics. So time is what? Distance by velocity. So you know the distance, you know the velocity. So here you can say it is distance. First, the time taken by the person to cover from A to B will be what? Distance by the time or the velocity. And here the person covers B to C in time. What is the distance? Distance covered from B to C, it is S2 by what is the velocity? It is y, right? So you can say it is S1 by x plus S2 by, this is the equation. So S1 plus S2 by S1 by x or S2 by y. Or if you are getting more confused in writing this v and y, sorry, this x and y, then we'll change that thing to say that, okay, fine, I'll change this x and y as v1 and v2. Then there will be no confusion, right? So instead of this x, I am going to write it is S1 by v1 and S2 by v2. So I hope that you got the points. S1 by S2 by S1 by v1 plus S2 by v2. If they are covering equal distance, instead of this different distance, as equal distance in different speed, what will be the average velocity? So in the second scenario, if an object, say this object is moving from A to B and then B to C. Say here the thing is that scenario is that this is S distance and from B to C is also S distance. But the object is moving from A to B in V1 meter per second and from B to C it have a speed of V2 meter per second. So how can I find out the average velocity? Here you know this equation 1, and substituting the value here, S1 is equal to S2 is equal to S. Then how will be the average speed looks like? So average speed will be equal to S plus S divided by S by V1 plus S by V2. And by doing simple mathematical equations or solving 2S, if I am just taking this S out, then 1 by V1 plus 1 by V2. So here you will get S cancel, and then the equation goes like that. So 2 V1 V2 by V1 plus V2. This is a very important equation. That is, if I want to find out the average velocity, then if the condition given is that the distance covered by the object is same but the velocity is different or speed is different, then average speed will be 2 v1 v2 by v1 plus v2. So I think that you got the points there, and just find out, this is a homework for you guys, if what happens if the distance is 3. So 3 velocities are there, distance covered is same, then what will be the condition there? So there you will get a clue is that 3, instead of 2 v1 v2, it will be 3 v1 v2 v3 divided by, that's a combination, v1 v2 plus v2, v3 plus v1, v3. So just see whether you can find out the things. So this is all about average speed and average velocity. Instead of this velocity, it will be, sorry, in the case of average velocity, the thing is that instead of that distance, you will just change that thing to displacement, right? Then you will get the answers. So that's all about average velocity and average speed. We can say that if an object is here, let us say A, and it is at x1 at time t1, and then the object is moving from A to B, and now we can say it has displaced x2 in time t2. Then how can I find out the average velocity? So here also, once again, I'm saying the velocity average is given by total displacement by total time. So here, what is the total displacement? The total displacement is x2 minus x1, because with respect to an origin, it is x1 displaced with respect to origin in time t1, and then it has displaced x2 with respect to the origin. So we can say that with respect to the origin, it has displaced x1. With respect to the origin, it has displaced x2 in time t1 and t2 respectively. So what is the displacement change here? That is x2 minus x1. Then you can say this portion. Okay, so it will be x2 minus x1 divided by t2 minus t1, or simply we can represent as delta x by delta t. Delta represents what? The difference. Delta represents the difference there. So delta x by delta xt, or delta x by delta t will be the average velocity. Now, instantaneous speed and velocity. What do you mean by instantaneous speed and velocity? So, if you're traveling in a car, you can see that there is a marker, right? And we call it as instantaneous, or speedometer. We call it as a speedometer. And here you can see there's a needle which shows the speed of that particular vehicle, right? Or velocity of that particular vehicle. So, let this be 0, 10, 20, 30, like that. There are certain ratings. In some premium cars, it will go up to 250, 360, something like that. What do you mean by that? Or what is the actual meaning of that particular reading or meter? Okay, so here you can see that if I'm just riding a car at certain positions or certain timings, you can see the needle keeps on changing. Sometimes it will increase, sometimes it will decrease, or like that. So what is the actual meaning behind, or what is the actual physics behind that particular meter or reading? And there it shows that at particular time, at that particular instant, what is the speed or what is the velocity. And we say that particular velocity or speed at a particular instant as what? Instantaneous speed or velocity at that particular instant. This is what we need to study. So we have seen that the velocity average or speed average is given by delta x by delta t. Delta x by delta t. So here you can see the time interval is a bit larger, right? So you can see that there is a certain like that, right? So just imagine that there is a timeline here, and an object is here, or a person is here. If he is traveling from 0 to 1, or 0 to this particular position in time interval 0 to 1, or 1 minute. Just imagine that it's 1 minute, right? So in that 1 minute time, the person has moved from A to B, right? So there is a time interval of 1 minute. If I want to find out the position of the object at this particular instant, so what should I do? I should reduce my time interval. Say that if I'm just reducing the time interval shorter, and then at last I can find out this particular point. Or simply saying that V instant or speed instant is given by limit delta t tends to 0. That is, I am just limiting my time interval to 0, or I'm just reducing it to a particular point delta x by delta. Then I can say this is known as what? V instant. Delta limit delta time tends to 0 delta x by delta t, or simply this will be changing, or V instant is given by dx by dt, differentiating. I'm just differentiating the distance or displacement with respect to time, then I'll get what? V instant or speed instant there. In the case, you can see that a differential process coming into play. So if I were to find out the instantaneous velocity, then differentiate that displacement with respect to time and you will get the value there. Okay, we'll have a clear-cut idea by doing one particular numerical problem, and then we'll understand what is the difference between the average velocity and the instantaneous velocity. So here comes a problem. So here is a question. A body is moving in a straight line. Here it is straight line along x-axis. So we need to find out the average speed and instantaneous speed, and the movement is given with an equation, with the help of an equation x is equal to 5t minus t squared. So this is the thing. So we need to find out the average velocity and the instantaneous velocity. So first one, we are taking the average velocity or average speed, the speed average. We know that average speed is given by the total distance by total time. So delta x by delta t. We need to find out delta x by delta t. So what is delta x here? So just imagine that x is equal to 5t minus t square. But here also one more thing is given there, t is equal to 0. We need to find out the x at t is equal to 0 and t at 2. So here what happens there? So here we need to find two things, that is t at 0 and t is equal to 2 seconds. So what will be the corresponding x there? So just imagine that x0, which corresponds the distance at t is equal to 0. So what will be that? So substitute the values 0 to t, then you will get the thing. So x will be equal to 5 into 0 minus 0 square, that is equal to 0. So x0 will be equal to what? 0. And x2 represents what? At t is equal to 2. So without confusion I will write x at t is equal to 2. So what is the distance at time 2? So there you will get 5 into 2. Substitute 2 value 2 for t. So minus 2 square. Then it will be equal to what? 10 minus 4. Then you will get 6 meters, or if I say x is in meter and t is in seconds, then it will be 6 meters. Here is 0 meter. So what is x is equal to 0 and x2 is equal to 2 meters. So what is delta x? Delta x is equal to what? Delta at t is equal to 2 minus x at t is equal to 0. Then that will be equal to 6 minus 0, that is equal to 6 meters. So delta x is equal to 6 meters. Delta t is what? Here t is equal to 2 seconds, t1 is equal to 0. Then we will get what? 2 minus 0, that is equal to 2. So there the average speed or speed average will be equal to delta x by delta t. Then there you will get 6 by 2, that is 3 meter per second. So this is the case there. First average velocity you will get 3 meter per second. So first you need to find out the corresponding x with respect to corresponding time, that is t is equal to 0 and t is equal to 2. Then you subtract and you will get, and divide it with a total time interval, and you will get the average speed there. So what about the instantaneous speed? How will you find out the instantaneous speed? Let us see what happens. Instantaneous speed is nothing but it is a limit delta t tends to 0 delta x by delta t, which is equal to d by dt of x. So here x is given by 5t minus t square. So what happens there? Delta or instantaneous speed insta is equal to d by dt of 5t minus t square. Simple differential thing, that is equal to d by dt of 5t minus d by dt of t square, d by dx of kx, where if k is a constant, then you can just take that k outside and dx by dx, that will be equal to 1. So that will be the answer. That means here also phi is a constant t. You need to differentiate. You can just take this phi outside and differentiate t with respect to t, then you will get equal to 1. So that's the case. And then d by dt of, or simply d by dx of x square, then a symbol or x raised to n, x raised to n, d by dx of x raised to n. Then if this is a form, then, and if n is a constant, then you can just write n x raised to n minus 1. This is the, so here also you will get what, d by dt of t square, then you can just take, write down t into t raised to 2 minus 1, or simply we can say 5 minus 2t, 5 minus 2t. So this is a thing. So instantaneous speed instant. Now you substitute, you need to find out the instantaneous speed at time t is equal to 2 seconds, and you know the speed insta is 5 minus 2t. You substitute the value of t is equal to 2, because you need to find out the instantaneous speed at 2 seconds. So that will be equal to 5 minus 2 into 2, that is 1 meter per second. In the case of average speed, you got 3 meter per second, but in the case of instantaneous speed, you got 1 meter per second. I hope that you got the point how to calculate the average speed or and instantaneous speed. So that's it for today's class. I hope that you got the points. So we will come with new topics, important topics in the next class. We need your support by your like, share, comment and subscription. We will see you in the next class. Till then, goodbye and have a nice day.